What's trigonometry? Well, here's the basic idea.
So I've got a bunch of right triangles. These are all right triangles, and this angle is the same in all of them, but they're all different sizes.
So the side lengths are all different.
But the ratios between the corresponding sides are the same. What do I mean? Well, take a look at this big triangle. It's got some height that I'll label in orange, and it's got some width that I'll label in blue. Now, the width of this triangle isn't the same as this triangle, isn't the same as this triangle, isn't the same as this small triangle, and the height of this triangle is different than the heights of these three triangles. But look at the ratio of this height to this width. All right, here's the height, here's the width, and if I double the width, it's a little bit more than the height. In other words, the height is just a little bit less than twice the width. And that's true for all of these triangles. The ratio of their heights to their widths are all the same, even though they're different sizes.
That's the key fact that makes trigonometry work. If you just draw some random right triangle with given angles, it doesn't really make a lot of sense to ask questions about the side lengths. It really depends on how big of the triangle you drew. But it does make sense to ask questions about the ratios of side lengths. Those only depend on the angles. So we can give names to these ratios. We call the sine of theta is the ratio between the height and the hypotenuse. So if you like the opposite side and the hypotenuse, it's y over r in this diagram. The cosine of theta is the ratio between the adjacent side and the hypotenuse of the right triangle. It's x over r in this picture. And the tangent of theta, that's the opposite side over the adjacent side. It's y over x in this picture. This is the sine, cosine, and tangent of this angle theta, and they're all just defined in terms of ratios of side lengths. Now that we've got a definition of sine, we can, for instance, calculate sine of pi over 5 if we build a triangle, any right triangle, with an angle of measure pi over 5.
I built a right triangle, and this angle is pi over 5. I can use my little ruler to measure the hypotenuse. The hypotenuse here is about 25.2 centimeters. And I can measure the opposite side, and the opposite side is about 14.8 centimeters. And sine is the opposite side over the hypotenuse, which means sine of pi over 5 is about 14.8 over 25.2, which is about 0.59.